is going to have? These are fixed pulleys. No, I'm not much bothered about this fixed pulley. Okay, there's no problem with this. Let's go for that movable pulley here. So that I'll draw a little bit big so that we can analyze it. No, this is a thread. You have to draw a diagram by seeing not possible. By seeing not possible, you should draw a diagram, show the forces, how do they move. But by mere seeing not possible, especially mechanics problems, maybe atomic structure, all atomic physics, okay. But especially mechanics, no, you should never take out your pen from the page. To that extent, the diagrams must be there. I think he has given diagram of this kind, so I'll retain the same thing. Okay, now you see this. This much is what we have here. And this is that movable pulley, no? It's asking its angular velocity. Okay, so what all we can do first, we'll do it. That's all, no? Now, what is this? This pulley is a light, no? So what will happen to the tension in either side? So I think we have to go back to our how to mobile. There's a light pulley. So first we'll go back to the some basics. Like if this is the pulley, I'll come back to the question. And now if there's a pulley is there, we will just suspend. I'll say this pulley is having a mass m. Then what will happen to the tension? Here the tension will be T2, the tension here will be T1. Then if M1 greater than M2, and I'll see that this will move down, this will move up. And because of tension acting, T1 will be greater than T2 and it will rotate. So T1R minus T2R should be equal to M R square by 2 alpha. This is similar to circular disk. So this is having a mass M. This is not a light pulley. Mass. It's having a mass M that I'm showing here and radius R. About what point the torque is set up? About O. If this pulley is massless, you look at here, if pulley is massless, if pulley is massless here, if this pulley is massless, then what will happen to the tension on either side of this pulley will be equal. I think that's what we did in laws of motion. No? Getting the picture now. So what is the strict condition here now? If the pulley is having a mass, the tensions will be different. Then again, one more thing, there will be friction between the pulley and the rope. So what will happen is as the pulley rotates, what happens? This particular block will move up, and there won't be slipping between the string and the pulley. This is what happens here. So you look at this one. There's a pulley, no, and there won't be slipping between the, and there'll be friction between the string and the pulley, and because of that, what happens? There won't be slipping. If the pulley is massless and there's no friction, then the pulley will not rotate, and it's a laws of motion problem. Agreed, all of you? If pulley is having a mass, suppose it's a pulley is having mass and there's no friction, tell me what will happen. The pulley will not rotate. Am I right? Because why pulley will rotate? Pulley will not rotate. Then if it's having a mass and there should be friction, then only what will happen? These conditions will come. If there's no friction, though pulley having a mass, then what conditions will arise here? Like this cannot rotate. There should be some sort of friction should be there. So that what happened, I think in most of the problems, they are taken for granted and you need to bother. Clear this? So I think the best thing is when pulley having a mass and it is naturally assumed that the tensions here will make it to rotate. You need to bother anything that one. Okay, I think that is what this conditions are being brought here. It's a massless. Then what makes it to rotate? Let's see that. The tension T. Now why tension? Because as it is massless. And the same tension will act here. And because of tension, this is having acceleration A1, this is having acceleration A2. What about acceleration of this point? Acceleration of point P1 should be equal to A1. And how much of tension here? 2T. Let's write some equations, then we'll see what will end up. M1 A, then on the right block M2 A. Sorry, M1 A1 T equal to M2 A2. So why accelerations should be different? The same force is acting, but masses are different. So therefore M1 A1 plus M2 A2. Then for this block, M0 G minus T2 equal to M0 A0. I'll write it. Acceleration of this, let it be A0. What is A0? And acceleration of the block M2. Acceleration of block M2 should be the acceleration of AP2. And AP1 should be equal to A1. So therefore, any relation between A0, AP1 and AP2. Go back to the pulley constraints. We did earlier some problems. So therefore here, A0 should be equal to AP1 plus AP2 by 2. So this should be equal to how much? A1 plus A2 by 2. The one very good equation what we handed up. Now can we solve A1? So let me put all the things. M0 G minus 2T is equal to A0, what I'll write it as M0 equal to A1 plus A2 by 2. Substituting A1 as T by M1. So M0 G minus 2T equal to M0 by 2. A1 is T by M1. Plus this will be M0 by 2. A2 is T by M2. Solving all this, we'll get expression for tension because T is only unknown thing, tension, that will get it. I calculated, so I'll end up with this one. You do check later on calculation. So this is a tension. After getting tension, we'll get A1 and we'll get A2. Okay, this is about all fine. Okay, like this we can work out. Such I think numericals are there even in most of the books. But how to get angular velocity? From where that angular velocity should be brought? After getting this tension, I'm going to substitute in these equations. I'll get the A1 and A2. Okay, now let's look at the pulley. What is the state of pulley here? It will be spinning. Why it is spinning? Because look at this acceleration. Acceleration of this end is A1, this end is A2 like this. So if you look at the pulley, so let's focus only on the pulley now. So this is the pulley is there. This point is having acceleration AP1. This point is having acceleration AP2 and it is rotating. Sir, how do you can say it will rotate? See, like if this is having acceleration here AP1, after that what happen? It should get acceleration AP2, no? Here, the acceleration of this point should be AP2. Then what when the alpha, if it is like this, then the resultant acceleration will become AP2. And what about the midpoint? The midpoint is having how much? A naught. Any equation can you write? AP1 should be equal to AP1 should be equal to A naught plus R alpha. R is the radius. Then what about acceleration of this point? AP2 should be equal to A naught minus alpha. The value of R alpha is such that R alpha will be greater than A naught. So this will be, sorry, like the A naught will be again greater than R alpha. So the resultant acceleration will be like this. So by the time this point of a string, when it moves from point P1 to P2, the acceleration changes. So the linear acceleration is varying. So therefore, it must have angular acceleration. If acceleration at this point and this point were same, then things would have been other way, that one. So how to, can we calculate the alpha? Yes, we know AP1. So what is AP1? AP, we know A1, A2, and we know A naught. So we'll get alpha. After getting alpha, so what is in fact alpha? You can write delta omega by delta t